So the topic acid, base, and salt, classified paper 6, question 8. A student investigated the reaction between a hydrochloric acid, dilute hydrochloric acid, and aqueous sodium carbonate, and he labeled the solution as L. Three experiments were done. In the first experiment, a measuring cylinder was used to pour 25 cm cube of solution L into a conical flask. So what student did? Student fill up the measuring cylinder to 25 cm cube and add that solution L. Basically solution L is a solution of a sodium carbonate. As I mentioned here, sodium carbonate solution are labeled as L. So 25 cm cube of sodium carbonate solution was added to the conical flask. Then 10 drops of thymol pathylene indicator was added into a conical flask. So we add drops of indicator. The indicator is added. Then a burette was filled up to 0.0 mark, means the burette was completely filled till the top, and the volume at like the marking there at the top is 0.0. Then a dilute hydrochloric, the burette was filled with a hydrochloric acid, so there is an HCl here. The dilute hydrochloric acid was added from a burette into a conical flask until the solution just changed to colorless. So when the indicator show a color change, then we will stop the reaction. The question is, use a burette reading, record the final burette reading in the table and complete the table. So what is the final burette reading?
Reading in progress.
What is the final burette reading? You can use the screen annotation to complete this. 11.6. Not 12.4. Whenever we are reading, that's a mistake, Basil. When we are reading a burette, we read from top to bottom. So how much volume is removed? So this is like 11, 11.5, then 11.6. And the difference in the volume, that is like the final minus initial, so 11.6. So how much HCl is needed for the first reaction? The first reaction, we need 11.6 cm cube of HCl. Without calculation, can you tell which solution is more concentrated, L or hydrochloric acid? Which solution is having a high concentration? Is it L or hydrochloric acid? Like sodium carbonate or hydrochloric acid? Hydrochloric acid is more concentrated because we need a small volume for a complete reaction. That's why. You can use your mic or a chat to answer. How hydrochloric acid is more concentrated, as you can see, if we are, when you write a balance equation for, so if we consider the ratio is 1:1 example. So the same number of moles in how many? It was 11.6 cm cube of HCl. So in a small space, more moles are there. That's why it is a high concentration. Ten drops of methyl orange. 10 drops of methyl orange were used as an indicator, and experiment 1 was repeated. Dilute hydrochloric acid was added, and until a solution show a color change, use a burette reading. So that is 23.6. And how much is a difference? So 11.6 is a difference. Yeah. So same amount is needed, 11.6. Then the third experiment was done. A conical flask was emptied and it was rinsed with distilled water. The experiment 1 was repeated using a methyl orange instead of thymol pathylene indicator. And add dilute hydrochloric acid from a burette and a conical flask until it shows a color change. The burette diagrams, you have to, what is the initial burette reading, final burette reading? Final is 20. 4.1. Initial is 0.9. And how much is the difference? The difference is 23.2. So 23.2 is the difference. Then what color change was observed in experiment 3? Look, experiment 3, you are using a methyl orange. First, you have, because methyl orange is added into a conical flask. And what was there in a conical flask? The conical flask was filled with sodium carbonate solution or alkaline solution was there, Na2CO3.
Yellow to orange.
So initially, because it was alkaline solution is there, so you will mention yellow. And then what will happen? We add an acid, so it will change to orange because HCl was there in our burette. So yellow to orange is a color change. You have to learn the color changes for like identify the color of indicator in different medium. So this will be yellow and the other one is orange. The next one, why a conical flask emptied and rinsed with distilled water at the start of experiment 3? What's the reason why when we start this experiment 3, why it was
To
rinsed with,
remove residue from previous experiment. If
yeah, to remove residue from the previous experiment or to remove the impurities, you can also say, or chemicals, leftover chemicals. Avoid contamination. No, the question is why it was rinsed. So it is was rinsed or if the question is why it was washed, so your answer, the proper answer you can mention to remove chemicals or to remove the substances or solutions. Contamination is also acceptable, like it won't contaminate, that's also fine. Then complete the sentence. Experiment dash needed the largest volume of a hydrochloric acid. Which experiment there was a greater difference? We did the 3 experiment. Yeah, that's right. So experiment 3 need the largest volume. Then give name of a more accurate piece of apparatus of measuring a volume of solution L. If you check in the beginning, we were using a measuring cylinder to measure 25 cm cube. What other apparatus can we use?
pipette.
So we can mention pipette. What would be the effect on the result if a solution
A
L was,
solution L was
The rate will be faster.
no, but the thing is overall result, will it affect on the overall result?
No.
No,
There will be no effect.
the titer will be same because moles stay same in
Yeah,
solution.
mole stays the same. So over because in this experiment, as we don't use a stopwatch to measure the rate or the speed of a reaction, so we are not using stopwatch or anything. So that's why effect on the result, we are just measuring the volume. So on measurement of the volume, no effect. And why there is no effect?
there's
Because
no
there are
effect because
same moles are used.
Sir, if we increase the concentration of the reactant, the result will be different.
Yeah, if you increase the reaction concentration, result will be different. You need a greater volume, greater amount for a complete reaction. Then the next one, determine the simplest ratio of the volume of a hydrochloric acid used in experiment 1. So 1 and 3, experiment 1, how much we used, that was 11.6. And experiment 3, how much it was used? It was, so yeah, ratio is 1 is to 2. 23.2 was there. Yeah, that's right. So the first experiment, it was 11.6. And the second experiment is 23.2. So the simplest ratio is 1 is to 2. Suggest why the volume of a dilute hydrochloric acid used in experiment 1 and 3 are different. What might be the reason why we need different amount of hydrochloric acid for a reaction? Experiment 1 and 3. We did not change the concentration. Look, solution L, same amount of solution L, same type. But the only thing is that we use a different indicator. By using a different type of indicator, you need a different amount, because as I mentioned, that indicators are also weak acids. So for example, the first experiment, we were having solution L, which was sodium carbonate, Na2CO3, that was 25 cm3. The third experiment also, we were having a solution L, that is same sodium carbonate, and that is the same volume. But the only difference, the first experiment we used thymol pathylene, whereas the third experiment we used methyl orange. So if we use even different amount of indicator, because it depends on type of indicator use and amount of indicator use. Like if you see the experiment, the comparison between the experiments. So the experiment one, if you see how many drops we added 10 drops of thymol pathylene. This one. If you check the second experiment, 10 drops of methyl orange. If you check the third experiment, so here they did not mention how much, like what amount of a methyl orange is added, like what quantity of a methyl orange is added. So instead, so experiment one was repeated using methyl orange indicator instead of thymol pathylene indicator, and a dilute hydrochloric acid is there. So why the results are different? The result depends on the type of indicator as well as amount of indicator used. So the simple reason, and if you see the experiment one, first we did experiment one, then we add indicator, then we continue the experiment. But experiment three, we rinse all and then add methyl orange. So the idea is that the first two experiment is like a mixture of two reagents, but the third experiment is totally methyl orange is there. So this suggests why the volume of hydrochloric acid used in experiment 1 and 3 are different, because we use different types of indicator, or different amount of indicator you can also mention. Is it clear? Second part. Suggests why universal indicator cannot be.
It will
So,
show a range. We cannot detect the endpoint
yeah,
from the
because
color ranges.
that's right. Because universal indicators show transition of the color. As there are like multiple color changes are there. In alkaline it will be blue, then in neutral it will be yellow, green, and then it will be orange, then red. So there will be a variety of a color change, so it will be difficult to identify the endpoint, exact endpoint at which, like how much acid has reacted with an alkali. So it will show a transition of the color throughout the experiment. So difficult to identify. The endpoint. Endpoint means like we are sure that what volume of acid has reacted with an alkali and the moment indicator show a color change. Suggest how a reliability of a result could be checked. How we can make sure that the experiment which we carried out or we did that is reliable. Whenever you want to check the reliability of the
Repeat
result.
the experiment and
So
spot for anomalous results which are not in range of other results.
yeah. So repeat experiment, and even you can mention repeat experiment until the values are concordant. Values are concordant mean, like example, they are in the range of 0.2, 0.2 more or 0.2 less. So till what time we should repeat? That titration experiment should be repeated. Like for example, you're carrying out a titration, you did the first experiment, you got the value as 11.6. You did the second experiment, you're getting a value as 11.9. You did the third experiment, you're getting a value of 11.1. So I have to repeat. Why I have to repeat? Until I have concordant result, like two results are 0.2 difference between them. Like once I get, for example, I get 11.6 or 11.7. So this 11.7 and 11.6 are concordant, like they're in the range. 0.2 more or 0.2 less, results are refers to concordant result in titration. So we should repeat the experiment. For titration, this is always the case. Repeat and until the results are concordant. So if you just, yeah, if you mention compare average, check for a spread result, that is fine. It is not wrong. You mention repeat experiment, compare the results, find the average, or find the anomalous result in the range. That is fine. But the thing is, for a titration specifically, whenever a titration is done, we repeat the procedure until we have two results which are 0.2 in the range. That is the way to carry out a titration.